Good day, guys. We're back again. This is part two of Laplace transform, and we're going to take over from where we left. Previously, we started with rule number 1 until rule number 4, and in this session, we're going to evaluate or investigate rule number 5 until rule number 8. So, as I mentioned previously, that when we talk about Laplace transform, we're just talking about an integral that basically move a function of f of t to f of s. So we're moving from the time domain to the s domain. So we are going to look into rule number 5, 6, 7, and 8 and see how we can solve such problems. Suppose you are given a function f of t which is equals to sine hyperbolic of 4t, and you are required to take the Laplace of this. First thing first, you need to identify the value of a. If you look at this rule number 5, a is the argument of sine hyperbolic, not sin, is sine hyperbolic. The h stands for hyperbolic, sine hyperbolic. You need to look at the argument of sine hyperbolic, and in this case you can see that the value of a is equals to 4. And then how are we going to take the Laplace of this? When you take the Laplace, we said Laplace is an integral that transforms your time function to what? To s function. So we are moving from f of t to f of s, and then now our answer is going to be a. Our a is 4 all over s squared minus 4 squared, which is 4 all over s squared minus 16. So this is how you solve using rule number 5. Similarly, rule number 6, let's say maybe you're given your function which is f of t, let's say h of t, which is equals to cos hyperbolic of 5t. You're going to do the same thing. If you look at the rule, it says if you are having the cos hyperbolic of 80, your answer is going to be s all over s squared minus a squared. You need to locate the value of a. Where is a? A is the argument of this guy. So it means for a is going to be what? It's going to be 5. So we have a as what? As 5. So if we take the Laplace of h of t, the Laplace of h of t will be what? Capital letter h of s, which will give us what? S all over s squared minus 25, because it's 5 squared. So this is how you solve using rule number 6. And then let's go to rule number 7. This is the most important rule. They love this rule a lot. I can assure you, or it's already there in your semester test. So with the rule number 7, it's a rule that talks about an exponential function. Let's say maybe you have a function such as, let's say f of t is equals to e to the exponent bt. You have this function. If you take the Laplace of this, the answer is going to be f of s is equals to 1 over s minus b. I want to emphasize on something. The exponent, if you are having b as positive, you're going to have your sign between s and b to be negative. But let's say maybe you had f of t, which is equal to e to the exponent negative bt. Your f of s was going to be 1 over s plus b. So the sign fluctuate. This function, this sign here and these ones, they are always opposite of each other. Let's look into an example. Let's say maybe you're given, they say, determine the Laplace of, let's say you're given f of t, which is equals to e to the exponent 3t. We know what the Laplace of f of t is what? F of s. Since it's an exponential function, it means we're going to look at rule number 7. So it's going to be what? 1 all over s minus 3. The sign was positive, it has to be negative here. And then let's look at another one. Let's say maybe you have f of t, which is equals to e to the exponent negative 3t. So the Laplace of f of t is going to be f of s, which is equals to 1 over s plus 3. Simple like that. Simple like that. So this is how you solve using rule number 7. Well, let's try to do another rule number 7 using what do you call this, using, let's say maybe we have a constant in front of the exponential function. So let's say we have h of t, which is equals to 25 e to the exponent negative 2t, ne? And you are required to solve this guy. You are required to take the Laplace of this. To take the Laplace of this, we know what the Laplace of of h of t is going to be capital letter H of s. It does not matter which function they give. If it's f of t, it's gonna be capital letter F of s. If it's z of t, it's gonna be capital letter Z of s. So any function that they give you is going to be in the time domain. You need to make sure it's in the s domain, ne? And then h of t is gonna be what? H of t is gonna be H of s, and then we need to take the Laplace of this. Since we're having an exponential function, we know what is rule number 1, rule number 7. So it's going to be 25 outside, and then 1 all over s minus what? Our b is what? Our b is this guy, which is negative 2. So it's gonna be s plus 2, and then you multiply inside the negative the 25, so you're gonna end up with 25 all over s plus 2, and then simple like that, you're done. And then let's look at the last rule for this class. The last rule is rule number 8, ne? Rule number 8 says if you have f of t, which is equals to t to the exponent n, which is being multiplied by the exponential function, which is raised to the exponent bt, the Laplace of this is going to be what? N factorial all over s minus b to the exponent n plus 1, ne? So you just have to look at the function. Oh, we have t to the exponent n is from t, ne? And then b is from the exponential function. Okay, cool. Let's say maybe you are given a function which is f of t is equals to t e to the exponent 2t, ne? And you're required to take the Laplace of this. If you have to take the Laplace of this, the Laplace of f of t will be what? F of s, which is equals to, now we need to identify n. What is n? N is the exponent of t, and we can see that n is what? Is 1. N is equals to 1. So using this rule, our answer is going to be n factorial, which means it's 1 factorial all over s minus 2 to the exponent n, which is 1, plus 1, which gives us 1 all over s minus 2, which is raised to the exponent 2. Simple like that. Well, let's do another last example based on the last rule. Let's say maybe you have h of t, which is equals to, okay, this color is not visible, h of t, which is equals to t squared e to the exponent negative 3t, ne? The Laplace of h of t will be what? Capital letter H of s, which is equals to, we need to have n. What is n? N is 2 here, so it's gonna be 2 factorial s minus s plus 3. Remember the sign we have to fluctuate. S plus 3 to the exponent n is 2 plus 1, which give us what? 2 all over s plus 3 all to the exponent 3. Simple like that. And then this is how we take the Laplace of rule number 5 to rule number 8. Simple like that. I can assure you guys, you are all going to pass the next semester test.